We're at time, so I'll go ahead and begin. So thank you all for coming to the talk this morning virtually. This is Automation Firehose, Be Strategic and Tactical. We're going to learn a little bit about how to employ test automation for a team or an organization. And you're going to get a special treat. This is a thematic presentation. You'll see there'll be a lot of Marvel characters, villains and heroes alike in this presentation. So what we're going to talk about today are some core concepts associated with building an effective automation solution, grounding ourselves in a little bit of history going back about 20 years for some of the efforts in the automation space. We're going to learn about what we should consider when selecting framework and tools, the overall approach to our automation program, some of the common challenges people encounter, how to integrate it into the SDLC, metrics that you concern about. I actually leave that at the very end as a lengthy portion for folks who want to check it out afterwards. Do not worry, I have this on SlideShare and I can share this information with folks who are interested afterwards, as well as some quality standards that we want to adhere to ensure our automation is going to be sustainable for the long term. First, a little bit of information about myself. So as mentioned, my name is Thomas Haver. I live in Columbus, Ohio. This is my second time speaking at Pittsburgh TechFest. Last time was in 2018 at the in-person event. If you're interested in learning a little bit more about automation or DevOps, I maintain a blog with my team called Red Green Refactor. Most recently, we're starting a book club on behavior-driven development. I was a scientist for 10 years prior to entering in IT, working in molecular fluorescence spectroscopy and microscopy. Also a gigantic board game fan. I own around 2,500 board games. They take up an entire room in my house. I'm also an evangelist for Ruby Cucumber. So I've worked in the automation space for a while, and it's my sort of preferred tool of choice. Lastly, I have a lovely family, a wife and 2 kids. My kids are fans of the kids board game. My wife mostly puts up with my board game collection, so much thanks to that. So a little bit of background about automation and efforts to make it successful on an enterprise scale. Let's set the groundwork though. Create a shared understanding amongst all of us. Strategy. Strategy is defined as a plan of action or policy designed to achieve a major overall aim, whereas tactic is the art or skill of employing available means to accomplish an end. Let's think about a good example here with the Avengers Infinity War movie. Star-Lord here had an excellent strategy for defeating Thanos in the movie. However, it was his own emotional tactics that ultimately cost the team in the battle against Thanos, and he was able to snap away half the universe. So we need strategy and tactics to be successful with an automation program. Let's take a trip in the Wayback Machine, all the way to 2004. Microsoft at the time maintained a pretty good blog, and they talked about the essentials for testing Internet Explorer, commonly considered one of the more challenging browsers to test or even to work on from an automation perspective. We'll consider it from Microsoft's perspective, a company that had to care about testing all of these combinations of Internet Explorer version as well as Windows OS anytime they wanted to push a change or service pack. Multiply each of these combinations by 26 different language binaries, and even for a company with the resources as Microsoft, it becomes quite a challenge to actually test any change that's going to go into their web browser. So how did they address this? Well, what we commonly refer to now as like risk-based testing or a form of persona testing is how they addressed it. They grouped together the versions of Internet Explorer with the versions of Microsoft Windows into actual viable versions. So certain versions of IE did not exist on certain versions of the OS. And they put them into buckets that represented customer profiles, whether that be large industry, commercial customers, or consumers. And based upon these buckets, they were able to more effectively test Internet Explorer rather than end up having huge gaps in their test combinations because there simply was not enough time to test everything. And this was even on the scale where we're talking about occasional deployments, not daily deployments that can go on now. So even Microsoft had a big problem with their test coverage. The promise for automation has always been that it's going to save time and lower costs while raising quality. But we see in practice, this is rarely the case. And most of the time, it's through a combination of misunderstanding about the management's expectation as well as the implementation. And that means that most people end up automating to get to the next day, to finish the story card, to finish our sprint increment, to get done with this project without a concern for the long-term consequences. The same as a lot of the sacrifices we make with developing the application itself. You make those sacrifices for good principles to be done. How do we actually address this? Well, all right, let's talk about concepts that we care about when we say we want to implement automation. This is also going back almost 20 years for L3D Dustin's implementing automated software testing. The idea goes is as the size of your application increases, the cost and time to deliver it also increases, and your associated test coverage and quality decreases. If at a certain point you sprinkle that magic automation dust over top of the application where you're able to use test automation, then suddenly, the cost and time to deliver decreases and your coverage increases. Again, sounds great in theory, but in practice we see rarely the case. And we want to address this. We want to make sure that as the state of our application goes from greenfield to brownfield, or is just a legacy application to begin with, and we want to add effective coverage around it, we want to make sure to follow good principles so that way we can actually be successful long term, that we actually get a return on investment for our automation. When I'm working with a company and trying to get them to adopt automation or putting in place a program that they had an idea about, I consider these primary areas of concern for strategy: scope, the objectives, the approach, the framework and tools, the environment, the schedule, and the technical skill set of the people on site. All of these are areas that we must consider in the overall strategy. The tactics are how we're going to achieve each one of these given areas. Let's talk about approach to begin with. So one of the issues that we have is people have different ideas about what can and should be automated, and they have different skill sets when actually doing so. So one of the areas that you want to help standardize and create rigor around is the simple question of what should we automate? This is an example of sort of a task list, almost a checklist that I actually use when I'm trying to get teams to first adopt automation. I send this with whoever is going to actually be responsible for writing that test automation to the tasking session or specification workshop. They're supposed to consider these questions. Is the test or task going to be repeated, and how often? How much time could be saved by actually implementing it? Is it subject to human error? Is it lengthy? Do you have a lot of setup that's involved from a data or an environment perspective? Prompting people with questions such as these will help them consider whether or not we should automate a scenario, whether it's a good candidate for test automation. The overall purpose of this is you want to try to make it as standard as possible across all teams, all applications that you support, and the determination for what makes a good candidate. So that way you're not needlessly investing in automation. And that is because when you are writing automation, when you're committing to writing it, it has to be maintained. You should treat it the same as you would development code. That is to say that every time you write a new test script, you are investing in that test script. You're committing to its maintenance costs. Those maintenance costs could be around our automation tooling itself, OS upgrades, language upgrades, upgrading the test every time the application is modified in that area under which you traverse, whether it's service layer, UI level, or backend, is something you're going to commit to updating as well. You also have costs associated with documentation and implementation and onboarding. So you're going to have to worry about training the people or making sure that they have the skill set, whether that's involved bringing in new people or uplifting existing people, and having that automation suite either be as self-documenting as possible or provide information around all these other basic costs. So investment in automation is not just simply writing the test, it's much more than that. We additionally have some organizational constraints which concern our overall approach. So we're always going to be limited by the delivery schedule, the project budget, and the technical skill set of the people on site. So we should instead automate based upon the frequency of use or criticality, which can include legal risk at times, whether it's, say, the CCPA, GDPR, or accessibility compliance. We want to look for complex manual scenarios that require data or environmental setup and help create a priority list for automation candidates. So we're always focused on automating those most valuable scenarios first and work our way down the list. A good way to do this is with a so-called automation scorecard. I have an example here. In this case, I replaced numbers with simple checkboxes just for simplification. On the leftmost column, we have a number of features that could be implemented for an application. In this case, this would be for an online banking platform. And then for each of the columns to the right of that, we are identifying areas of our own concern. Now, this is just a simplified list. The list I typically use is about 10 items long, where we consider things like, is this on the critical path, or is this going to be executed frequently? Login, absolutely. Like, that's a path that's going to be generally considered for almost all flows. Do we have to address some legal compliance with this feature, in which case it does provide some additional value? Is there a lot of test data management or environmental setup that is necessary for this? And can this be scenario reused again and again? So if we have to have login as our entry point for the application to do anything else, then that's a high degree of reuse, and that makes for a good automation candidate. You want to create a scorecard like this, and you end up having a rating system. In my situation, I do from 0 to 10 for each one of the items for 10 different items. So the scale goes from 0 to 100. Once you commit yourself to a project, you can then have this list work from the highest priority items, which have the highest score, work down to the lowest items. So if you're always limited by time or budget, you know at least you're focusing on those most important, and those items that are farther down the list, you've at least identified automation technical debt you've accrued if you're not able to get to it in time. Also consider adding in potentially a threshold. If it doesn't meet a certain score level for you, then it's put aside. It's not potentially a good automation candidate. Even though you can automate it, it doesn't necessarily mean that you should. So what makes good test automation? This is about changing that mindset, not only of the management, but of the people on the team for the purpose of that test automation. It's important to understand that automation is supposed to enhance testing instead of replacing it. Us conducting exploratory testing activities, the manual testing activities, are just as valuable, if not more so, than automation, because automation is there as a tool. It's not supposed to replace those testers. It's supposed to be an additional tool that will help us, whether it's us scheduling that execution or that execution being part of a CI/CD pipeline. We need to make sure that our automation is written concurrently with our development code, that it is part of that definition of done. So that way we go beyond simple checks into something that's more informative. The UI-based automation itself should be based upon the actual user experience. The automation also should be something that's focused and informative, as in it should be covering the valuable components of our application. And it should also be trustworthy and repeatable. If you send off reports to your stakeholders, to your team members, and half of the tests fail all the time, how likely are they to actually check through that report after a few times seeing all these failures? It needs to be trustworthy and repeatable, as in you need to have very few failures, and the failures you do have should be good indications of actual defects to address. I'll go on to that a little bit from the tactical perspective. But first, let's jump into our framework and tools. So this is often a big choice that a company has to make, or a choice where they have to shift off of existing tool that did not work. And it's one that can often lead you down the wrong path. So I'm going to give just an example here. I'm not saying this is the best. I'm saying this is an example of many. So let's just say we are testing an application and we want to make sure that our results, our automation, is visible to all members of the team. Well, in that case, you would use something like this. This is Gherkin. For those of you who don't know, it's written in given, when, then format of here's a context, here's a change of state, and here's an outcome. The top layer is plain English for this automation, so that makes it more accessible to everyone. As I mentioned at the beginning, I'm a fan of, say, Ruby Cucumber, but it's not the only automation tool I've used. There's a lot of commercially available tooling. a lot of available open source tooling. In this case, I prefer going more with open source because it overcomes some of those cost barriers that you'd have. And also, if you use popular tools, it's more likely to have a lot of support, a lot of updates, and you can overcome a lot of other problems if you're encountering, because likely someone else encountered the same. So in this example, this is a web application that's driven by Selenium, which is an open source tool, using Ruby and Cucumber to write the language. You want to try to align your tool with the application under test. This is why I say if you're going to test, say, web applications and focus on UI, then using Selenium is a pretty good bet. Why? Well, Selenium has been implemented in the most popular programming languages. And this is a piece of advice I can give to you. You want to try to have your test automation ideally written in the same language as your development code base. Now, that's sort of self-evident for something as a unit test, but for your integration, as well as your functional UI tests, you want to try to line them up. This is because you want to try to keep your tech stack as small as possible, and you want to expand the scope of who could potentially write those automated tests to not simply be members of QA who have learned to write automation, or people you brought in as SDETs. You want your developers to care about this just as much. What is their favorite programming language? Well, it's the language that they're using to write their application. And so if you can align your test automation to be in the same language as your application under test, you're going to have great outcomes, because that means more people are able to review the automation, to write the automation, and you can have your functional test automation live right alongside your application. So this is why when you're selecting a tool, you don't want to just say, hey, go with something that's nice and shiny or something that's been sold to you. You want to make sure it's a good fit for your organization. More than framework and tooling, we care about our actual standards. So we'll go back and use another example written in this Gherkin format for a validation that's being performed. You want to have your people focused on testing activities and not maintaining the framework underneath the covers. You want to make it as hands-off as possible. So here an example written in that plain language, we have the implementation under the cover for each one of these steps, where we see that we've put in place a lot of reusable steps that aren't going to require us to write anything new. Think about from the perspective of a web application. When we say the user clicks insert name here, that could be any number of objects on the page you want to click on. Just by passing in whatever object you want as the variable means that this little bit of code, these 5 lines for clicking on an object, are highly reusable. You don't have to actually touch this bit of code. You want to try to minimize the amount of work you have to do for the framework. And what you see here is not what I would say considered to be the best example, because this is written in an imperative style, like the UI element interaction. This is sort of a code Lego that we're using. What we want to do to make those long-term improvements is turn these imperative steps into declarative steps to describe like what the user is accomplishing rather than how they're doing it. So you use these little building blocks and you wrap them up into statements like, hey, given the user is logged into application as insert type of user here, that handles all those steps of opening up the browser, putting in your username and password, clicking login, saying no to surveys, and finally getting to the account overview page. So you use these little tiny imperative steps and identify what are some core features of your application, what your user would accomplish, and wrap those into single declarative steps that are highly reusable. And then you have to minimize the amount of time you're spent coding underneath the covers. You're focused instead on writing those tests. Another area of benefit is using persona testing. I mentioned at the very beginning of Microsoft's sort of implementation of persona testing 16 years ago. This is very similar. So Alan Cooper, who wrote The Inmates Are Running the Assignments, and personas are incredibly useful when you don't have easy access to real users because they act as user stand-ins, helping to guide your decisions about functionality and design. So let's think about it from the perspective of whether we're a tester, a web developer, a requirements analyst, or product owner. What would we want to do? Like, we want to consider the perspective of the user that will help us prioritize those most valuable features because we care about how our end user is interacting with the system. We want to design our automation to match this end user behavior. One way in which we can help drive our automation, calling back to our automation scorecard, is using that marketing data. How are our users interacting with our site? Are there any locations in which they are quote unquote bouncing, as in leaving our application? Let's look at the logs, find out where the greatest source of errors are. This is the area where we want to focus our testing. You can take this one step further. So this is an implementation of persona-based testing in a cloud-based testing platform, in this case, Refactor Mobile. So you can identify your users and then divide them up based upon features, what they're attempting to accomplish. We can go further and say, all right, let's just say we're going to test for mobile applications. We can break down based upon our customer profiles of device, geolocation, network profile, background apps, to really build out valuable automation. Automation that just becomes another variable from the persona perspective. You want to choose something like simple names that represent those people. So that way, when you're developing features, you're developing them to Mary or Bob that match a given user profile. And your automation will end up matching that user persona. So we're writing valuable automation that's help accomplish the goal, whether that's simply getting a user to check out of your e-commerce platform or conduct their online banking. These are valuable ways to make automation visible to all and focused on what's going to drive value for your company. To this point in time, I've talked a lot about UI automation and given several examples about that. But that's not the end all be all. Although I would say the UI-based test automation is probably the most popular when we're talking about a lot of the training that's going on and a lot of what people publish. More valuable than UI automation are integration tests. Why? Well, they execute more quickly than that UI-based test. They are more robust, and they allow us to find issues earlier in our application development lifecycle. Another benefit of integration tests is there are frameworks that are written in pretty much whatever language of choice you want for the application under test, like Spock, Jasmine, Fitness. So it's recommended that you prioritize integration tests over those UI-based tests. If we're going to extend this, unit testing is also something that is highly valuable. Why? It's the fastest method of testing our application. It provides easier way for us to debug. It's highly reusable, and it allows us to find things more quickly than others in the life cycle. Again, the same benefit is you have unit test frameworks that are in whatever language you want. So you match, of course, the language of your application to have unit tests in place. So your priority should be unit test first, followed by integration tests, followed by your UI and end-to-end tests. This should be how you actually implement test automation from a priority standpoint. But there's several challenges along our path to automation success. Here's a few of them that I've encountered in helping out some companies. So one of those is the aforementioned automation Firehose, the name of this presentation. And that is because people have a habit once they learn a new tool to try to use it everywhere. Everything looks like a nail if you're a hammer. Just because you can automate something does not mean that you should. You want to instead adopt a risk-based approach for your automation, exactly as I described with that automation scorecard or the checklist to determine candidacy. These are things that will help ensure that you're automating only those most valuable items. Use evidence to base your decisions. Another area of concern is data failure. Test data management is probably one of the biggest concerns related to software quality. So you write an automation script and executes in, say, your QA environment. You promote it to stage and it fails. And it fails also in prod. Why? Because you've written your script and hard-coded your data for a single environment. You're not getting the most return on investment. Instead, as an upfront concern, as in before the team begins work, you need to ensure that your automation is cross-environment compatible. That means test generation for that data, as well as manipulation of that data as an upfront. You don't want to have a lot of quote-unquote selfish data that executes as part of your automation. You want to do setup and tear down of your data the same way you would expect of your environment. You want to make sure that your automation can run independently and successfully across multiple environments. That's how you help maximize ROI. Another area of common concern are so-called flickering or flaky tests. So these are tests that you execute, they pass, you run it again, fail, execute again, pass, fail, flickering, red, green, red, green, red, green. These are bad tests because good automation is informative and trustworthy. If you have tests that seemingly pass, fail every time you run them, people will stop caring about the results. What you should do is remove any of those flickering tests. That becomes automation technical debt. You want to do a failure analysis. Find out what the source is. Is it due to data? Is it due to environment? Is it the application under test that's having issue? Third-party dependencies? Or is it our own automated scripts? You know, sometimes our own coding is not up to standard. So we need to make sure first to remove them from our execution so people aren't wasting their time chasing potential false failures, or we have false passes. And we want to investigate the reason why and address it. If we can't address the underlying concern for that flickering test, it should not be executed as part of our project work, as part of our regression. Remove flickering tests. Another area that we see of common concern are those so-called long tests. Tests that are 300 steps long, validate a few dozen things. It's bad for a couple reasons. One of those is simply, if you have a failure for your automated test, say 15 lines into that 300 line scenario, you're going to skip a whole lot of validations. Another is simply readability. If you can't understand what the test purpose is, or your eyes sort of glaze over because it's so long you don't know where it's actually going, that's a bad test. They should be simple and informative. You want to make sure to focus your automated testing on unit and integration as priority. Add in the UI and the end-to-end behavior that's focused on that persona-based testing as needed. So those tests are valuable. You don't want to have 1,000 tests or tests that have 1,000 lines in them that validate a whole bunch of things when you should be focused on simple, informative tests and provide fast, valuable feedback. Another area where people commonly run into issues is that shaky foundation, as in they will build their automation suite to work for the next day and they'll skip out on the rest. And so you're building on top of a shaky foundation from a framework perspective. Your architecture is not going to be sustainable. It will break after a couple of years, and then another group that comes along will have to discard it entirely and rebuild it. You're ruining your return on investment in that case. What you should focus on is to treat it the same way as you would development code. That means maintaining those good practices in the industry, like don't repeat yourself, or KISS, keep it simple, stupid. You want to include code reviews, code analysis tools, and refactoring sessions to make sure that as you add new features to your application under test, that your automation is of good quality. The last common challenge that I note is you lagging behind development. You write your development code, say in one sprint or for 1 month for a project. And then in the next month or next sprint is when you actually write your automation scripts. Or maybe the project has actually gone to production and then you start writing your automation. You don't want to be in that situation. You want to automate during the sprint. You want to make sure that your automation is an upfront concern as part of that definition of ready, and completed scripts are part of that definition of done. I'm going to show you a bit about how to integrate that in. So scheduling is a big problem. Like, how do we schedule automation to be written along with development work, especially if we didn't have any automation to begin with? Well, one of those techniques is using example mapping by Matt Wynn, he of Cucumber fame. So example mapping is about using those behavior-driven development principles of discovery, formulation, and automation. It's a collaborative technique for example mapping. Most of you probably heard of similar techniques like Three Amigos or specification workshop. Well, in an example mapping session, your focus is a single user story or feature to be developed. You're going to have representatives from the team for quality, probably our tester, developer, product owner, business analyst. For that single user story, they're going to first identify the business rules to be implemented. Think about this is the business logic that the developers have to actually put in place. For each business rule, you're going to come up with one or more examples to illustrate that rule. This is from the user's perspective. This is us writing our test cases. You will additionally identify any questions as those red cards that anyone in the room is unable to answer. This allows you to go back to architects or outside vendors or other people in management or other application SMEs to provide you some feedback before the team says, okay, thumbs up, we're ready to go. We can actually begin development. This is a way to empower the team to prevent work that is not ready from entering the team space. Some good benefits of using example mapping is your examples become user scenarios. You can ensure that you've got good coverage from the business logic standpoint because you have at least one example to match each business rule. You create a shared understanding amongst members of the team about what needs to be accomplished. And by preventing work that is not ready, you reduce the amount of rework that has to be done by the team because they have to redo once they actually demo it because they misunderstood what was meant by the business. Some good feedback mechanisms. The reason why we have a color-coded example map is if you have a lot of red cards in an example map, that is a good indication that development work is not ready to begin. You should reject that story, send it back until you get these answers. If you have too many blue business rules under an example map, that is a good indication that that user story might be too large. You need to break that user story apart into 2 or more stories. If you have too many examples underneath a given business rule, that is a good example that that rule is too dense and it must be split apart into 2 or more rules. And this way, the color coding helps support us in understanding, all right, is the story something that can be consumable? Do we have good test coverage that can be implemented as automation scenarios? And for our business rules, hey, we have something that we can write our unit and integration test to because this is the business logic to be implemented. So that's a good approach to adopting automation and making it an upfront concern to ensure we have a shared understanding. But we also want to adopt some quality standards to ensure our automation is going to be maintainable for the long term. One of those techniques is with a regression review. So oftentimes with automation, people will leave in scenarios, same as manual test cases in the quality center or ADO or Jira X-Ray. And those tests will become out of date, but they'll still be kept there. So we want to make sure that our regression is fresh. So what you do is you want to have your test lead compile a list of all the new release scripts, as well as the existing regression scripts. You're going to have your prod support provide metrics on incidents that you had for your application to understand where you have areas of need. You're going to have your business provide metrics on application usage broken down by feature to understand where users are interacting with the system. And lastly, your app manager is going to provide a list of upcoming projects, level feature changes, that sort of mixing between business and technical side of where we're going. These 4 people coming together will help identify what new scripts should be added into the regression, what should be removed because it no longer reflects the current state of the application, and what are areas of need going forward. This helps us understand that our test automation should reflect the current state of the application, and we should have good coverage that matches where people are having issues, where people are helping generate our revenue, and where we're going for our application roadmap. Another area of concern when we want to maintain quality in our automation is using practices like code reviews and refactoring. I've shown a lot of superheroes and a few supervillains throughout this presentation. Well, here is my personal superhero. It's Martin Fowler, he of refactoring fame. He said, I'm not a great programmer. I'm just a good programmer with great habits. So one of those habits we want to adopt are code reviews. Just as we would expect our application we're developing to be code reviewed, so too should we code review our automation. So what are some principles we should follow? Well, we want to make sure that the candidates we've identified are actually automated, that they're understandable by the team, not just the person who wrote them, that they represent the current state of the application. We don't have old scenarios that no longer provide any value that we're just going to fail. We want to make sure that we don't duplicate any effort, that if we're going to actually write more code underneath the covers, that we're not reinventing the wheel here, that we've identified the data needs, the object needs to actually execute the scenarios, and that we've maintained team agreements for how we're going to write that top layer, how it's going to be traced back to our project tracking tool. This should all be part of code reviews to ensure automation is long-term sustainable. We should also conduct regular refactoring sessions, not just as an individual activity by an automation developer or an application developer, but by the team coming together. The principles of refactoring require us to have maintainability for application, extensibility, and a good understanding of that domain knowledge. A reminder that our automation code should be treated with the same care as the development code. That means that when we're conducting refactoring sessions, we care about the performance of our scripts. We want to obey non-orthogonal design. We do not want to duplicate efforts, nor do we want to have outdated knowledge be represented there. But it's one thing for me to just say, hey, you should conduct a refactoring session. It's like, how do you actually do it? Like, let's get to that tactics portion of it. Well, the way in which I recommend is formalizing it, making it a regular occurrence on a weekly basis. You have one person who's identified as the team leader for those refactoring sessions, responsible for scheduling, the delegation of work, the focus areas you should have for that session, as well as any bug reports generated when you discover issues. You should have an outside oracle as an automation guide. This is someone who's strong technically, who can help keep track of the live session, who will generate action items to give to the team leader, and is responsible for tracking that improvement status report as in areas where we're going to show that we are increasing the quality of our automation framework while adding in new features. What focus areas should you choose for a factoring session, which is often a concern people have when they come to me. Well, I say, well, go by your code metric report. Choose a given feature that someone on the team is working on or an overall project release. Everything that is tagged regression is an opportunity, as well as from a CI report, look at those logs, see where you have failures or warnings. Those are areas where you're going to end up focusing to address. And it's recommended you focus on just one of those items that I have in the bullet point. Keep those sort of guardrails around you to provide structured refactoring session and make it part of your regular practice rather than as an exception. So in summary, what did we learn today? Well, first off, our priorities. Our priority should always be on unit testing over service level testing, on service level over those UI automated tests, and those UI tests over those end-to-end that cross application barriers. We should also understand that we're not writing automation for everything. We're building based upon that probability of failure, the impact on the business, and the complexity of those scenarios. We should also build based upon our constraints of budget, scheduling, technical skill set of the people on site. It's always going to limit us. So why set ourselves up for failure? Let's work within those constraints to be as successful as we can be. So with that being said, I have an additional section that is at the very end that's just intended as reference around metrics, because I know people want to track like how well are we doing? What are our key progress indicators? I've done that for people who want the presentation. I have it as listed here at the very bottom. You can see hosted on slides here for anyone who wants to see it. I'm also available to send it out. Do we have any questions? I'll stop sharing and go to the chat window here. People are ready.